Hi everyone, how are you doing? Okay, so today we are going to start a new topic which is called correlation. Okay, it is, similar to covariance only, but covariance has one small problem. So that is why we need to introduce one new topic which is called correlation. Okay, so by the way, have you attempted the quiz, the recent quiz that I have uploaded? Okay, let me show you. See here on the gate or flow. So there is a quiz, right? This probability quiz. Okay. Let me just check. Yeah, not much people have attempted. Okay, so just attempt this quiz, right? Just attempt this quiz. This is having a good number of questions. So just attempt this quiz. Okay. So this is how many of you have attempted from here? And how was the quiz? Was it too hard? Was it too easy? Were you able to solve questions related to covariance matrix? I put two questions related to covariance matrix so that you get to understand these kind of concepts more. Okay, so Mitali is saying some questions were tricky. Yes, yes. So, but you must have learned something, right, from those questions. So let's just do one thing. Let's just put one more quiz of the similar type. Okay, so similar type quiz on this coming Wednesday. Okay, the similar syllabus will be there, right? Okay, so the questions will be similar to this quiz, and there will be 15 to 20 number of questions, and then you will be, getting these concepts more. So now let's just start a new topic, which is correlation. Okay. So in covariance, we have seen that this particular number, okay, the covariance number, this number doesn't signify anything, which means if you're measuring something, let's suppose in unit of 100, then it might be 16.5. But if you divide for the same data, if you divide x and y, let's suppose by 10 and by 10, then the covariance will be divided by 100. So it will be 0.165, right? It will be 0.165. So approximately it is 2. 0.2. So basically what I'm saying, with the same data, if we change the scale, okay, from x to x by 10, similarly from y to y by 10, if we change the scale, then the covariance is changing, right? Is this okay to everyone? So, so if we change the scale, then covariance changing. So which means covariance number doesn't say anything. Okay, so I can say here that changing the scale, basically changing the scale from x to x by 10 and y to y by 10. This is basically, this thing is saying that that the covariance changed, right? Changed by divided by 100. Okay. So basically this number 16.5 is covariance or 0.2 is covariance, which doesn't say anything. So which means that by looking at the covariance number, you can't infer anything. So you can just say, okay, you can just say if covariance is positive, then they are positively correlated. Okay, positively correlated. If covariance is negative, then they are negatively correlated. Can I say if covariance is, let's suppose 100.35, then they are strongly correlated? Can we say they're strongly correlated? Very strong correlation. Tell me. The answer is no, right? We can't say anything. Answer is no. Okay. So basically, this number doesn't tell you anything, right? This number magnitude doesn't tell you anything, right? It doesn't tell anything. So basically, the magnitude of the covariance doesn't tell anything. only sign matters, right? Sign tells that correlation is positive or negative. So that's why we have something called as correlation here, which is basically dependent. I mean, here the value will tell you something, okay? The correlation value will also tell you something. So how it is defined? Basically, it is defined just for the covariance. If you divide the square root of the variance, do you remember this standard deviation? This standard deviation is nothing but sigma of x is nothing but square root of variance of x, right? How many of you remember it? So generally we write variance of x as sigma square, right? Generally we write like this. So basically this is called standard deviation. Okay. So the correlation between x and y is defined like this, which means covariance of x by divided by standard deviation of x into standard deviation of y. Now here, if it is +1, then they're typically big together or small together. So basically they are strongly correlated, or the maximum value could be +1, minimum value could be -1. Okay. So let's just see this. So see, correlation between x and y is nothing but if you just make the standard form of this, okay, standardize these random variable x and y, which means x minus expectation of x divided by standard deviation of x. How many of you remember that if you want to standardize any random variable, then you need to do something like this? From the module 1, subtract the expectation and divide the standard deviation. So the correlation formula is coming from the covariance only. It is just that you need to make them standard, okay, standard random variable, which means given the data, if you just make the data center aligned means that expectation of this standard and standard variable is always 0, right? So center aligned means if you subtract the expectation such that the expectation of this quantity will be 0. Okay, so if you just make it center align and divide by the standard deviation, then you find the covariance. Then it is nothing but the correlation. Okay, so this covariance of this standard variable and this variable is basically the covariance between x and y divided by standard deviation of x, standard deviation of y. Do you want to prove this using the properties that we have seen? Which means suppose if I ask you to prove something like this, okay, that find out the covariance between u and v. U is something like this and v is something like this. Then can you say that this is sigma x, sigma y? Can you take it outside? Divide by sigma x into sigma y. Is this okay to everyone? Tell me. Using the properties of covariance. If there is some constant, you can take it outside, right? Okay. Now, does it matter you are subtracting or adding to any standard any random variable? Does it matter? No, right? So this is exactly equal to the covariance of x and y divided by standard deviation of x comma standard deviation of y, right? Very easy proof. I mean, there is nothing much to prove here, right? Okay. Now, as I told you that covariance, we can also prove it. Okay, if necessary, we can prove it. The covariance value ranges from -1 to +1. +1 means this is strictly linear, okay, which means +1 actually we can prove this also. If let's suppose there is a random variable y and y is related like this, ax plus b or something like this, okay. If y is having linear relationship, strictly linear on the same line, strict line, okay, then the correlation between x and y is actually either +1 or -1, assuming here it is +1, okay. I mean, assuming the slope is positive, so it is +1, or it could be -1 also, depending on the slope. So if it is strictly linear, which means if y and x is having this kind of relationship, then the correlation will be +1 or -1. Okay, maximum value could be +1, minimum value could be -1. Here these values, okay, 0.5 means they are positively correlated. Then these values will also tell you that how much they are related. Unlike the covariance, in the covariance, does this value matter? only the sign matter, right? So these values doesn't really matter. So for example, if this is 0.8, then it means they're strongly little strong correlation, which means they're tending to linear. Okay, tending to the linear correlation. 0.5 means, yeah, it is still good. Correlation 0 means they're not correlated at all. Negative means they are like related with the negative slope. Okay, so let's just see examples and then you will get to understand more. So suppose they are saying I have two red pens, one green pen and one blue pen. I choose two pen without replacement. Let X be the number of red pens and red pens that I choose, and Y be the number of green pens. So X is the red pens, Y is the green pens. Then the joint PMF of X and Y is given like this. Suppose you have basically two red pens, right? And one green pen. So you can choose maybe 0, 1, 2 from the red pen, 0 and 1 from the green pens, right? So now what they are saying is that this is a joint PMF, which means the probability you don't choose any red pen, and let's suppose you choose one green pen, is 1 by 6. Okay, something like this. And then what they're asking, okay, so suppose they're asking you to find out the correlation between X and Y, right? Suppose they ask you that calculate this quantity. Okay, so how to do it? You know how to calculate covariance, right? So using the covariance, you can calculate this. So basically you need to calculate first covariance and then variance also, because correlation need the variance, I mean the standard deviation at least. So let me just show you the example here, and then we will be doing more questions. So for example, this is the joint PMF that is given, right? Okay, so the expectation of X, you can calculate easily. How you can use this formula? Yes, you can use this formula to calculate the expectation of X. So basically expectation of X will be, you can say expectation of X will be double summation X, Y, and then X into the PMF, right? Joint PMF. So can you tell me like at which quantity X is not 0? So basically these four quantity will get considered, and now here the PMF itself is 0. So basically these three quantities, right? So X value is 1 here. So 1 into 1 by 3 plus 1 into 1 by 3 plus, so you can say 1 into 1 by 3 plus 1 into 1 by 3 plus 2 into 1 by 6, right? So how much it is? This is 2 by 3 plus 2 by 6. So which is 4 by 6, 6 by 6, right? 6 by 6, which is 1. Okay, so that's how you calculate the expectation of X. Now you also need to calculate the variance. How to calculate the variance? You need to calculate basically the expectation of X square also. Okay, so if you calculate the expectation of X square, then you calculate the variance. So you need to calculate these quantities, and then once you calculate these quantities, this expectation of XY, then you can calculate the covariance using this expectation of XY minus expectation of X into expectation of Y. Okay, so this is, let's suppose it is coming out to be 1 by 3. Then correlation will be covariance divided by square root of 1 by 3 into square root of 1 by 4, which is square root of 1 by 12. So it is minus 1 upon root 3, which means that the correlation is negative, which means if you are choosing, okay, more, here it is shown that if you are choosing, let's suppose more, if X is increasing, then Y is decreasing, right? If you are choosing, you can say the more X or the more red pens, then you are choosing less green pens. Okay, as you can see here, if you're choosing, let's suppose more, if X is 2, then it is very, okay, the probability that you will be choosing, for example, probability with that you will choosing X is 2 and Y is 0. This is 1 by 6, and the probability that x is 2 and y is 1, it is 0, which means they are saying that if x is 2, then choosing y, no y, basically, okay, here it is x is 2 and y is 0, then there is some probability. And if x is 2, which means you are choosing two red pens, and then there is a very less chance, or there is almost negligible, that y is also increasing, which means you are choosing green pen also. Okay, so it is almost negligible. I mean, it is actually zero probability that if this is high, then at the same time this is high, this is actually very less probability or zero probability. Okay, something like this. So basically they are negatively correlated, you can say. Okay, so let's do more questions and you will get to understand this particular concept more. So for example, here they are saying, suppose x and y are the two random variables. Now, variance of x plus 2y is given to be 40, x minus 2y is given to be 20. What is the covariance? And if variance of x and variance of y, okay, variance of x and variance of y are having this relationship, then what is the, this quantity is also called correlation. I mean, this is the notation, okay? This is a notation for correlation. Then what is the correlation? Let's just do it. Okay. So this is easy question only. Let's just try doing it. Do you want to try it quickly? So what is the covariance of x comma y? Let's just see. Okay. Do you remember this particular, expansion, that variance of x plus y is actually, how much it is? Variance of x, variance of x plus variance of y plus 2 into covariance of xy. Do you remember this? How many of you remember? So actually we can also prove this particular relation using the basic formula of variance, right? So for example, if you want to prove variance of x plus y is this one, then how to prove it? You can easily use the basic formula, which means as variance of this is nothing but expectation of this minus expectation of this whole square, which means if this is, let's suppose, some random variable, then expectation of x square minus expectation of x whole square, right? Okay, so what you can do, you can just expand this expectation of x1 square plus x2 square plus 2 x1 x2, right? Minus this quantity, which you can do one thing here. This is the whole square, right? So that's why what you can do, this is expectation of x1 plus expectation of x2, right? Now, you can just apply the linearity here. Expectation of x1 square plus expectation of x2 square plus 2 into expectation of x1 x2, right? Minus, now you can apply the formula here, which is a plus b whole square, is nothing but a square expectation of x1 whole square plus expectation of x2 whole square, and then okay, and then plus 2 into expectation of x1 into expectation of, you can say, x2, into expectation of x2. Okay. Now, once you have this, then what you can do, you can basically just see if any term is getting cancelled out. So this is expectation of x1 whole square. Okay, this is obviously not getting cancelled out, but you can write like this. This is 2, right? 2 into expectation of x1 x2, and this is also 2. So you can write like this: expectation of x1 square minus expectation of Okay, these are the brackets, right? These are the brackets. So you can put the x1 term together minus expectation of x1 whole square. Similarly, plus expectation of x2 square minus expectation of x2 whole square minus 2 into expectation of x1 x2 expectation of x1, and then yeah, this is x1 x2 only, expectation of x1 x2. Okay, so I hope you can do it from here. X1 x2 minus expectation of x1 into expectation of x2. Okay, so this is the variance of x1, this is variance of x2, and then what is this quantity? Is this covariance of x1 x2? Tell me, what is the formula of covariance between x1 and x2? This is expectation of x1 x2 and then minus expectation of okay, so I think this will be plus, right? Expectation of x1 into expectation of x2. So this is covariance, right? So this is variance of x1 plus variance of x2, and then this is covariance. Okay, so you can see here, that's how you can easily prove it. Okay, using the expansion you can prove it. Okay, you just expand it and then you can prove it. Okay, so basically what I'm saying here is that this is the formula that we know, right? Now here in the part A, they're asking the covariance. Okay, they're asking this quantity, and then they have given this particular quantity to be, I think, 40. And then similarly, this quantity is also given. So now just be careful whenever you are dealing with the, sorry, not this quantity is not given. Basically, this has to be 2. So that's why this is 2. But you take it outside, then it will be 4, right? And then this is 2. But you take it outside, it will be 4 or it will be just 2. It will be 2 only. So it is 2 into this. Now this is given to be 40. Similarly, this quantity is given to be 20. Now, just if we are dealing with the minus, then in that case, this will be plus only because minus 2 square is plus, but this will be minus. Okay. So then I think you can, they are asking you to find out the covariance, right? Then I think using these two equations, you can find out the covariance. So let's just see this. So this is given to be 40. Now here, just notice that this is plus only, but this is minus. Okay. This is 20. So this quantity is 40, this quantity is 20. So from these two quantities, what you can do, maybe if you just add them, will this be helpful to find out the covariance? No, covariance will get cancelled out. But if you subtract them, right? If you subtract them, then this will get cancelled out. This minus this is 8 and this is 20, right? So it is 20 by 8. Okay. Yes. So which is 5 by 2, which is 2.5. And then you need to find out the correlation. Okay. So for correlation, they have not given you the variance explicitly. They are saying you that this is the relationship between the variance of x and variance of y. Do you want to try for the correlation? So it is covariance upon square root of variance of x into square root of variance of y. Right? Now, this particular quantity is given to be square root of 2 into variance of y. So it will be square root of 2 into variance of y. Okay, so given this, I think you need to plug in into one of this, and then you need to find out the variance of x and variance of y, and then you can solve this, right? So it is a normal arithmetic. So let's just see the answer. So for example, we get solving these two equations, we get, so basically they have explicitly calculated the variance of x, variance of y or variance of x, whichever you want to calculate, and then you can calculate the correlation. Okay. Now let's solve this question. What they are saying. If the covariance of two random variable is equal to 400, we can say for certain that if the covariance, they are saying covariance, okay? If the correlation, the covariance is 400, then the correlation between two variables is negative. Can you say this? No, obviously no. The correlation between two variables is less than 1, but greater than 0. Can you say it is greater than 0? Less than 1 and greater than 0. Can it be equal to 1? Maybe, right? Maybe equal to 1. You don't know, right? So less than 1 may not be necessary. Maybe equal to 1. The correlation between two variables is positive. Can you say this? If the covariance is 400. Yes, right? Because since this is positive, that's why this is also positive. Okay. So basically C is the answer. Understood? Because since this is positive, so correlation will also be the positive. But the exact thing you don't know. The correlation will have the same sign as the covariance. The magnitude of the correlation will depend on the magnitude of the covariance, but also on the variance of which of each variable which we are not given. Okay, so it will depend on the variance or the standard deviation, whatever you want to call. Right. Now let's see this. Suppose x and y are the random variables whose joint PDF is given something like this. Okay. Now they're asking you to find out the covariance, variance, and the correlation. So how to find out the covariance? We need to find out the expectation of xy, expectation of x, expectation of y, right? And how to find out the variance? For the variance, what you need to do? You need to find out the expectation of x square, expectation of y square. These quantities you need to find out, right? For the variance. For the correlation, you need to find out the covariance, which you can do this. And yeah, so these expectations you need to find out. Once you find out these expectations, then you can find out all of these quantities. Okay. So how to find out the expectation of xy? It will be integrate over 1 by y. What is the limit of y? So let's suppose it is dy, right? So initially let's just put for the limit of x. What is the limit of x? 0 to y, right? And the limit of y will be 0 to 1. Okay. Cool. This is dx dy. Or maybe you can do in this way. Suppose you do dy first. Then in that case, what is the limit of y? Y is always greater than x, right? So maybe you can write x to 0. Sorry, x to 1. Okay. And then once you do this, then dx, the x can be 0 to 1, right? So you can solve like this or like this. So anyway, we will be having the calculus lecture. In that, I will explicitly, will be having more lectures in this double integral. Okay, there we will be solving many questions related to double integral and some complex questions also, so that you can easily put out these limits. Okay. So yeah, so they are using this first method, I think. Okay, 0 to y you can put, and then this is 0 to 1. So these expectations you need to find out the covariance. And for the variance, you need to find out the expectation of x square, expectation of y square to find out the variance, and the correlation will be then will be easy, right? So this is just a numerical question where you need to find out all of these quantities. Now let's go to the next question. So what they're saying, again, the same thing, right? Covariance, correlation. You can do this question as a homework. This is the case of discrete. Earlier was the case of this continuous. Answer is on the next page. You just try out, okay? Try out these variance, these covariance. Answer is on the next page. So just try, okay? Answer is on next page. Again, the solution itself, right? Solution is on. Okay. Now let's see this question. Which of the following is true, right? For any random variable xy, the expectation of x minus expectation of expectation of x minus ex into y minus ey. Have you seen this quantity somewhere? What is this quantity? What is this quantity? Yes, this is, I think, this whole thing, right? Including this expectation. This is, okay, this particular quantity without the square, right? So without the square, I can say it is the covariance. This is the covariance of x comma y. Now what they're saying, the covariance square should be greater than the variance of x into variance of y. What do you think? See, what is the formula for correlation? Maybe we can try with the correlation. What is the formula for correlation? The correlation says correlation between x and y. It says it is the covariance between x and y divided by square root of variance, or maybe the standard deviation, variance of x into square root of variance of y. Now, if you take the square both side, it is square, it is square. Okay, if you take the square both side, then you can say that basically it is always less than equal to 1, right? So if you take the square both side, you can say the covariance is square, covariance xy square, right, should be less than equal to variance of x into variance of y. Okay, variance of x into variance of y. Let's just check it. So it should be less than equal to, no? For any random variable, it is greater than. No, it should be less than equal to, right? There exist random variables such that it is greater. No, right? It is never greater. So this is false. This is false. For any random variable, this is less than equal to. Yes, right? So there exist random variables such that this is less than equal to. Obviously, right? Yes. So basically, you just consider this to be a MSQ question. Is or R2, okay? Is R2. This is, assume this is MSQ question. So these C and D are true, right? Okay. Now there are few questions. For example, this is one of the question. Do you want to try this question, or you can do this as an homework? This is easy question only. They're asking, these things are given. They're asking, this means correlation, okay? They're asking variance of x minus y and the correlation between x minus y, x and y. Okay, you can just try it. Solution is on the next page. Okay, this is easy question only. You can just try it. This is an homework. Now find the correlation. Okay, the covariance is given, variance is also given. So I think it's very easy. So what is the correlation? It is 1 upon. Can you tell me quickly? 1 upon. Yes, 2 into 2, right? Which is 4. So it is 1 upon 4. That's very easy. Okay. Suppose x and y two random variables, and like, okay, these are the easy questions only. You can just try these questions, right? Is this a repeated one? I think by mistake I pasted 2 times, but that's fine. Okay. So let's just see this. If x and y are, okay, this is normal distribution. Okay, this is normally distributed like this. What's the correlation between x and y? So this means mean. Okay, this is basically the expectation of x. So basically they have given to you like this. Expectation of x is 1. Expectation of y is also 1. They're normally distributed like this. Okay, and this is the variance. Okay, so variance of x is given to be 2. The variance of y is also given to be 2. Okay, so actually the normal distribution we will see tomorrow also. In the central limit theorem, it is very much useful. So we will see this normal distribution again tomorrow. So this is basically mu, you can say, and sigma square, right? This is the notation of normal distribution. Now these quantities are given. They are saying the correlation of x and y. Okay, so they have also given the expectation of x plus expectation of y, which is obviously 2, and the variance of x plus y, they have given that to be 1. Okay, so I think you can do this question, right? Okay, so you can just apply this formula and then you can do this. Now let's just go to the next question. They're asking the correlation, these variance, these things, right? So these are just simple numeric questions. You can just try out these questions. Okay, I have put these questions so that you can have more practice. Okay, just try it quickly so that you get to habitual of these kind of mathematics. Just try it quickly. Okay, answer is on the next page. Let's see this question. Suppose that x and y are the random variable defined. There is some random variable they have defined something like this, which is actually something like a standard random variable of x, and z is some standard random variable of y. Which of the following is generally false? Okay, so which of the following is generally false? Covariance between these two and correlation between these two are same. Is this true? What do you think? This is a good question, I think. See, do you remember how the correlation is defined? Correlation between x and y is nothing but the covariance between their uh, standard, you can say the version, right? Standard random variable. So the correlation between x and y is nothing but the covariance between their standard versions. So I think A is true actually. Okay, A is true. Is this fine? See, the correlation between, or maybe the covariance, or let me write the correlation between any two random variables is same as covariance between their standard versions, right? So that's why it is true. Okay, so let me just write it true. What about this? The variance. What do you think the variance will be for the standard random variable? Yes, this is always 1, right? And the mean is 0, right? The expectation of W into Z is something like this, the correlation. So what do you think? The correlation between X and Y will be basically the covariance, right? Okay, let's just think about it. What do you think? And what do you think about it? Okay, these are the two terms that are still left. See, what is the expectation of W and what is the expectation of Z? These are, tell me quickly, these are 0, right? Because they're a standard random variable. So for that, this basically the expectation is 0 and the variance of W and variance of Z is 1. Okay. Now, this correlation between X and Y is nothing but covariance between W and Z, right? So this is nothing but covariance between W and Z. Okay. And if this expectation is 0, then this covariance is nothing but this quantity, right? Are you getting my point? So basically, this correlation between X, Y is nothing but covariance between WZ. Okay. That's how this correlation is defined. The correlation is nothing but the correlation, the covariance between their standard version, right? Which is nothing but expectation of WZ minus expectation of W into expectation of Z, which is nothing but in this particular case, it is expectation of WZ. Okay. So this correlation between X and Y is nothing but expectation of WZ. So this is true. So I think this is also true. Okay. What about this? Yes, this is actually false. It doesn't have any, I can say any backup. So basically, you can expand this W, you can expand this Z if you want to. It is X minus, let's suppose E1 upon sigma 1, okay, X minus E2 upon sigma by minus E2 upon sigma 2, like this, right? So if you expand this, it will be variance of XY plus minus something, okay, plus something minus something, something like this, right? So it will be not variance of XY. Are you getting my point? So see here, for C is this, right? So I think answer is D. For A, the proof is available in the node. For B, okay. For C, this is the case, right? So answer is D. Basically, there is no relation between this variance of WZ, product of WZ and product of XY. Okay. So yeah, it was little better question. Now let's just see this question. Define W as this for general N and M. Okay, what is this N and M? Okay, maybe there was some earlier question, some part A or something, which I have not noted down, but that's fine. So prove that the correlation between X and W is 1. Okay, so they are saying that you have some standard random variable, and they are saying that that you need to prove the correlation between X and that standard random variable of X only to be 1. Okay, so how to prove it? Wow. So Ajay has written very nice proof. So Ajay is saying that to prove it, what we can do, we know this correlation is defined like this, right? By the definition, it is defined like this. It is basically covariance between the standard version of X, which is W itself, and since W is the standard of its, so it is just W, right? Which is nothing but variance of W, and which is 1. Wow, that's very nice proof. Okay, so this is really a very nice proof. So let's just see how they have proved it. Oh my God, they have proved it, a long way or something like this. But yeah, this is really a nice proof. Have you understood this proof? How we went from here to here? Because the correlation between any two random variable is nothing but the covariance between their standard versions. Okay, a standard version of W is W itself. A standard version of X is actually W because that's how it is defined, right? And now this is nothing but variance of W, and standard, if this is standard random variable, then the variance of that standard random variable is 1. That's really a very nice proof. Okay. So by the way, can you say that correlation between X and W, okay, is either +1 or -1? Because I told you something in the initial part that if they're following, if two random variables are following strictly linear relationship, which means y equal to, for example, W equal to some, AX plus B or something like this. If they're following strictly linear relationship, in that case, the covariance, it is either +1, correlation, it is either +1 or -1. Do you remember this? Right? So it is either +1 or -1, and it is very clear that it will be obviously +1. Why? Because if X is increasing, then it can't be the case that it's standard random variable W will be decreasing, right? So obviously it will be increasing also. So basically it must be +1. This is the intuition that I'm telling you, but yeah, mathematically it's very nice proof. Okay. Or if you don't want to prove this way, then what you can do, you can find out the expectation of W. Okay, something like this. They have okay, expectation of W is anyway 0. If you want, you can find out. Then the covariance between the X and W, you can use a covariance formula. This is very long, right? Equal to, and this is very long. If you want, you can try it. But yeah, I really like this particular method, which is given by Ajay. So that's really nice method. Okay. Now let's see this. Which of the following is generally false? Do you want to try this as an homework? Answer is on the next page. If you want, you can try this. What do you think? Okay, great. So you can try this as an homework, right? Answer is on the next page. You can try it. Now let's see this question. Suppose x has the mean mu and the variance sigma square. Z is a random variable independent of x which has mean 0 and the variance something like this. And y is something like this. And then they are asking you to find out the correlation between x and y. Okay. So correlation between x and y. It will be covariance between x and y divided by square root of variance of x, which is sigma x, square root of variance of y. So variance of y will be just variance of x plus variance of y because they are independent, right? So it is basically, let me write it separately. Variance of y is nothing but variance of x plus variance of y because they are independent. Sorry, variance of z because x and z are independent. So this is variance of x is sigma x. This is sigma z. Okay. So here you need to sigma x square plus sigma z square. These are the variance. So you need to write sigma x square plus sigma z square. Okay. Now you need to find out the covariance between x and y. Can you use the formula that we talked multiple times? X plus z. So what is this? This is the covariance between x and x. And then between x and z, what is the covariance? 0, right? Because they're independent. So basically it is the variance, or maybe let me write first covariance of x and x plus covariance of x and z. This is nothing but variance of x and this is 0, right? Because they're independent. Now variance of x is actually sigma x square, right? So if you plug it here, then it will be sigma x square divided by sigma x into sigma x square plus sigma z square. So I think what is the answer? Yeah. So basically, if you solve this question, then you will be getting, I think, A is an answer. Okay. Yeah, A is the answer. So that was easy question only, but yeah, nice, right? Well-framed question. Okay, this is very much possible to ask in gate because here they have used multiple things, right? For example, this formula, right? That you must be knowing. For example, this particular relationship, how to expand for the covariance. These things, little bit things you must be knowing. This is very good question, I think, and they can definitely ask this kind of questions in gate. Okay. Now let's see this. Suppose these are the scatter plots that are given. Now what they are saying? They are saying match the correlation listed below to the above scatter plot. Notice that once correlation one, okay, actually it was one correlation will not match. Basically, they are saying that okay, which graph is having the correlation at 0.5? Can you tell me which graph is having the correlation 0.5? Visually, what do you think? 0.5 negative. I don't think it will be having 0.5 if it is related like this. So I think this is not possible. This is very linear. Okay, this is there, this is there. Okay, actually only one will be matching. Okay, so for example 0.5 and 0.95, 0.25, these are the three positive: 5, 9.5 and 2.5. So which one is 5, which one is 9.5, which one is 0.5, which one is 0.95, which one is 0.25? Let's just check. 9.5, I think A, right? This must match with A. Okay. So in terms of the positive, so these are the positive. So I think 9.5 must match with A. 2.5 seems like B. 0.25 seems like C. Sorry, 2.5 seems like this is D, right? D. 0.25 seems like C. Okay. For the positives, I think these are the case. And minus 0.95, minus 0.75. Okay. So for the negatives, minus 0.95, minus 0.75. What are the case? Uh, Only I think B is remaining. So B is minus 0.95, or it is just like intuition based question. Okay, minus 0.95 or minus 0.75. What do you think? Is it too linear? Is it too strict, too linear? No, right? It is not too linear. It is little bit scattered. So minus 0.75. Yes. So it will be B. For minus 0.95, you can say no match. Okay. Just one graph will be matching one. So minus 0.5 is no match. Yes, no matching plot. And 0.5 is D. 0.95 is A. 0.5 is D. 0.95 is A. Yeah, rest is correct. Okay. So this is the answer. Now let's just check this. If the sample covariance between two variables is 1, okay, then there must be a strong relationship between the variables. So they're saying covariance. Covariance is 1, not the correlation. Can you say something that very strong or something like this? If covariance is 1. Okay, covariance. This is not correlation. Since it is there talking about the covariance, that's why it is false. Okay. Why it is false? Because they are saying that covariance uh, is 1 doesn't inform you anything about the correlation. Okay, using the correlation you can tell, but using only the covariance you can't tell. Understood? Okay, so this is the reason that this is false. Now let's just solve this question. This question has been asked in GATE 2021. Okay, just try solving this question. Actually, in computer science they have asked. Okay, not in GATE DA. In computer science, generally they have not asked anything related to the correlation, covariance, but this was the only question they have asked in past 40 years. Okay, sometimes they ask out of the syllabus question. In CSE syllabus, these kind of things are not there. In computer science syllabus, these kind of things are not there, but yeah, they've asked it, but that's fine. So just to let you know, this is modulus operation. Okay, this is modulus. This is multiplication of the modulus. So tell me, the covariance, is the covariance defined with the modulus operation? No. So that's why this is false, right? So I think this is false. Okay. What about this? This particular quantity, this whole quantity is nothing but square of covariance. This is covariance of xy square, right? We generally write the covariance like this also. Okay. I mean, I think I told you this is this is, you can say, the variance of x. This is the variance of, for example, y, and this is the covariance between x and y. How we write the correlation? What is the notation of correlation? Something like this. Okay, rho xy. This is correlation between x. Is this fine to everyone? Okay, great. Now they are saying that square of covariance xy square is greater than or equal to variance of x into variance of y. So I think we have done similar kind of thing. So the correlation formula says that this is this true? No, this is less than or equal to, right? Instead of greater than or equal to, it should be the less than or equal to. Why? See, the correlation between x and y is defined to be covariance between x and y divided by sigma x into sigma y, right? The sigma are the the standard deviation, which is less than or equal to 1 and also greater than or equal to -1. Okay, if someone asks you. Okay, so basically you can say, if you do the square both side, okay, you just take this and you just square both side, it will be like this: covariance of xy square, okay, this quantity is less than or equal to sigma x square, which is the variance, sigma y square, right? So this is basically, this quantity is less than or equal to this variance. So basically this is the variance only, right? This is the variance of x, this is the variance of y, right? Okay. So this is greater or equal to, this is false, right? So actually for gate CSE, these kind of things, are very, very tough because these kind of, things are not being taught in gate CSE because we don't need it. Okay. So for gate CSE students, this question was one of the toughest question of that year. Okay. But now it is one of the easiest question because we know the concept. Okay. So for gate CSE, trust me, it was the one of the toughest question for that particular year. Okay, in 2021, the paper was hard because of because of these kind of questions. But actually, this is out of syllabus question for CSE, right? For GATE DA, yes, this is very much in the syllabus. So that's why what is the answer here? I think both are false, right? So D is the answer. Right? Okay. So this is one question, by the way, that was there in the sample paper of GATE 2024, GATE DA. Okay. So this is GATE DA sample paper. This is GATE DA sample paper. You can just try out this question as a homework. Okay, this should be the easy question. You can just try out. If there is any doubt, you can just let me know. Okay, you can just let me know over the Telegram. We can discuss this question, right? Okay. So I think related to the covariance, related to the correlation, I just wanted to discuss these things only. So basically, why we need correlation? Because because the covariance doesn't this value doesn't give you anything. Okay, this is not standardized. But if you make it standardized, which means if you take the corresponding standard random variable, then this is the covariance. Okay, so the correlation between x and y is nothing but the correlation between the corresponding standard random variable. Okay. So Ajay, it's correlation coefficient only. Okay. It's just a name, it's just a correlation coefficient. So that's how we have motivated the correlation. And then we have solved few questions. We have understood the geometric meaning and these things. Okay. As an homework, what you can also do, just find out the correlation between, okay. For example, you can just try out this question also. So as an homework, if y is defined like this, okay, where a and b are the constant, then find out the correlation between x and y and check that it has to be either +1 or -1. Okay, so you can do this as a homework and just let me know tomorrow you can just send me the screenshot on the Telegram or the photo on the Telegram where you have proved it. Okay, so and tomorrow I will post your solution in the slides, so you can just send me the photo of the solution. Okay, so just prove as a homework. Okay, if this is having the linear relationship, then the correlation is either +1 or -1. Okay, it has to be a strict linear relationship. Okay, now we are now very much set to move into statics. Okay, so we will be starting with the statics, for example the hypothesis testing, and we will be having the very first and very important theorem, which is central limit theorem. Okay, first we will understand the central limit theorem, and as well as like we will be doing little bit more practice with the normal random variable. Okay, because that is necessary for the central limit theorem, and then we will be moving to something called as t test, z test, confidence interval, and these things. Okay, so basically it will take, I think, 5-6 more days to finish these 2-3 topics, and then we will be all set to finish this particular subject itself. Now here on the Wednesday, I will keep one more quiz for correlation, covariance. Okay, these things. Okay, covariance, joint PMF, joint PDF. Okay, these things. Okay, so that you have more practice. Okay, thank you everyone.